Oh, wow. Fancy meeting you here in space. And no, I don't know what's happened to my face. I think my face is full of space. Smash News Network, the busted name in news, is full of space. And thanks for tuning in to the Daily Space Weather. Congratulations on realizing the channel exists. We've begun the festivities today with 304 plus 195 angstroms from the GOES-R. And no significant uptick in solar activity since yesterday. We've seen some degradation. We've seen some new sunspots that need to be named, and we've seen some likely new sunspot groups. As far as flares, they've been underperforming. Let's take a look at the northeastern limb. I believe there is another sunspot hiding behind these active regions somewhere back here. We see a lot of plasma suspended out in those areas. The northwestern limb, a little bit less exciting over there, not too much going on. The southwestern limb features a degrading sunspot, that's 3272. This one rapidly grew, and it's quite close to the equator. We are still seeing sunspots at vastly different latitudes as solar cycle 25 progresses, and the most interesting spot is indeed the southeastern limb. A series of no less than 4 or 5 large sunspot groups have risen down there, and almost single-handedly raised all of the stats. So here's yesterday plus today. That's our solar intensity gram from SDO. Again, you can see this sunspot is still growing. So as this approaches the limb, this is becoming very likely to produce large flares. So we've got 3 places to expect to see large flares in the coming 24 hours. This sunspot group right here, this group down here in the southeast, and also this group in the northeast. So those are all pretty likely spots to see large solar flares of M or even indeed X-class. Here are the colorized magnetograms, also from SDO. We also saw some interesting earthquakes, so we'll be covering that here momentarily. And before we do that, take a moment to visit the links below the video. If you haven't, today's featured product is Smash Up Price, My First Pandemic. And don't forget to enter the promo code TEACH20 to save some cash, 20% on your checkout for your Redbubble orders. So this is actually a reintroduction. This is one of the first pieces of merch that we ever created. And, you know, sadly, COVIDiocy is looking like it's not really being cured. Tons of people, I see people every time I go out, masked alone in the car. Well, maybe not every time masked alone in the car, but I see people every time I go out masked. I guess they haven't read history about the historical efficacy of wearing masks to prevent infectious diseases. Again, enter the promo code TEACH20 to save 20% on checkout for your Redbubble shop. So if you're planning on picking up some items for the summer, now's a good time to do it. If you want to support the channel via a subscription service, consider becoming a member of the Smash Team at smashomash.com/Smash Team. That's the official subscription services site of the Smash News Network, least busted name in news. Thanks to our gold and silver Smash Team members especially. There's also a bronze membership level, and we do send out email alerts for videos just like this one to people just like you. Thanks again to all the Smash Team members. Are you signed up for email alerts at smashomash.com/Smash Team? Maybe you ought to be. Also, check the links below the video, as well as on the homepage for the Hemp Lucid shop. There's a huge 420 sale going on through April 20th. No surprise there. 40% off. So use our link to shop. Don't forget to enter the promo code SMASHOMASH on your Hemp Lucid order to save some dough over there. Our homepage, again, is smashomash.com, so help us out with clicks if you're unable and or unwilling to open your cobweb-encrusted wallet, and help us out via paying us a few bucks per month to create these videos. And welcome to the Neo-Renaissance, a reawakening of critical science. Thanks again to our gold and silver Smash Team members. These videos were brought to you in part by them, as well as by Smash staff and I at massive personal risk and expense. Next, let's go over volcanoes. Shivaluch continues to erupt as we're forecasting some purple skies over North America. Wait a couple more days, and you can expect to see images all over the internet of it. Shivaluch is still producing a 20,000-foot ash plume as it explodes. It's a flight level 200. Also, Bezimiani showing up there on the list. An actively growing lava dome happening there. Also, block and ash flows continue to travel down the southwestern flanks, and some fine dust plumes, otherwise known as phoenix clouds. Abico is exploding as well. That's a flight level 090. It's a 9,000-foot plume of volcanic ash over Paramushir Island. Semeru exploding, flight level 130. It's a 13,000-foot ash plume over East Java. And Aniakchak has had its volcanic alert level raised to yellow as a result of seismic activity and ground uplift over the Alaskan Peninsula volcano. Aniakchak raised from green to level, volcanic alert level. Popocatépetl exploding, producing a 19,000-foot ash plume over central Mexico. Fuego in Guatemala, 15,000-foot ash plume. Nevado del Ruiz, 21,000-foot ash plume. Sangay, 21,000-foot ash plume as it explodes. Revenador exploding, flight level 150. And 240 over Sabancaya. Sabancaya is exploding in Peru and producing a flight level 240. It's a 24,000-foot ash plume. And check out earthquakes. We've now gone to a high level of seismic activity. 2 major quakes to talk about. Let's hope these are not foreshocks. First of all, off the coast of Vancouver, there was a 6.0. There's the location of that quake. That came in at 15:54 Universal Time yesterday on April 13th. And there was also a 7.0 off the coast of Indonesia, right there in the Java Sea, a 7.0 magnitude earthquake. That one came through at 9:55 Universal Time just this morning, so just a couple of hours before we created this video. By the way, no tsunami warnings, watches, advisories, or threats at the moment. So if you are concerned about a tsunami possibility, head to tsunami.gov. By the way, we do send out email alerts at the Smash Team website to things like tsunamis, often before USGS does. Anyway, we'll scroll up the list here. Again, a 6.0 happened off the coast of Vancouver. That was at 15:54 yesterday afternoon, Universal Time. Philippines also had a 5.1. And again, any earthquake can be a foreshock, folks. So when you get a warning like that, heed the warning and keep your eyes open, because any earthquake could be a predecessor to a larger event. 5.2 in Indonesia also occurred. That was at 3:01 Universal Time this morning. Again, that 7.0, that was off the coast of Indonesia in the Java Sea. 9:55 this morning, and then no surprise there, a 5.4 aftershock. Hoping that was the major earthquake. Continuing on to go back to space. And this is the fantastic 195 angstroms wavelength from the GOES-R. We've also got the 304 angstroms wavelength. That's helium star. 304 angstroms represents the ultraviolet emissions from super hot ionized helium. And just like 195 angstroms, 171 angstroms is iron star, one of the many species of ionized iron that we show you regularly on the channel. Let's talk more stats. The 10.7 centimeter radial flux, now at 160 solar flux units. We're expecting to see this continue to increase in the coming days. The forecast for tomorrow is 163 for the 10.7 centimeter radial flux. Again, currently at 160. You see this black line, that's the radial flux for the past year. And the red line below it is a sunspot number. We can expect another several sunspots to be added. So expect the sunspot number to be approaching 150 plus today when some new sunspots get named. We'll get to it in a minute. Space Weather Enthusiast dashboard here, not forecasting anything besides a little bit of possible geomagnetic unrest late in the day, just before midnight tomorrow on the 15th. Now, we are expecting a minor coronal mass ejection impact to strike sometime between midday and the end of the day. So that could cause as high as maybe a KP6, but we're expecting that to be for a very short period of time. It was a stealthy, rather diffuse, and not particularly violent coronal mass ejection, but it was sort of directly at the Earth as far as we could tell. So it produced a slight signal on the coronagraphs. Again, we're expecting a minor CME impact late in the day tomorrow on April 15th. And if indeed we do see such a thing, we will be attempting to get some imagery of the aurora here in Pennsylvania, although we doubt to see aurora as far south as Lehigh Valley, Pennsylvania. Next, we'll look at Earth's magnetic moment from space. Here's the space weather modeling framework. Magnetohydrodynamic pressure for the past 4 hours out to about 12 Earth diameters. We'll let it play through in its entirety. These geospace magnetosphere movies are shown daily on the channel, as they are not accessible, as far as we know, in archival form. So things pretty calm here. We did see some minor upticks in the aurora, just as a result of mainly magnetic field changes. We'll get to it. So here's the past 4 hours of Earth's magnetic moment from the ground over the northern hemisphere. And that magnetic field shift that we saw, that we'll explain here in just a moment, did spark some decent aurorae. Once again, that's the past 4 hours. We'll also show the globe view. There's the full globe magnetic perturbations map. That's geospace delta B. Magnetic flux density is the unit that is being shown in the imagery. That's nanotesla magnetic flux density. Earth's magnetic moment from the ground for the past 4 hours. And geomagnetism is still calm here. So it's only a KP 2.33. Just a minor uptick there in geomagnetism. KP 2.33 is the current situation. Now we'll look at the real-time solar wind measured outside of Earth's magnetosphere at Lagrangian 0.1. So this is what was responsible for that little uptick in the aurora there. Just that shift in the vertical component of the magnetic field. So it shifted into a strong negative signal there, and that was sufficient to create some aurorae. That creates more induced currents in the Earth system. Current conditions for the solar wind are only about 350 kilometers per second for the solar wind speed. Solar wind density here about 3.7 protons per cubic centimeter. Quite dense and fairly slow. So if we do see a CME signal tomorrow, it should be pretty decent, as we aren't expecting any other space weather besides that in the coming days. Next, we'll look at magnetic data. GOES magnetometers here are pretty smooth. Pretty unremarkable, nothing to report on there. That arc jet moment there, that is the use of their thrusters to maintain the orbit of the GOES 18. And next, the heliospheric current sheet. So I do suspect that there is a sunspot hiding behind the northeastern limb. So that's something to look at for the coming days. There is a South Pole current sheet coming, and if that is a really strong sunspot, it could accelerate that current sheet. It could be here as early as tomorrow's video, but at the latest, by Sunday, we expect the South Pole current sheet to show up. There's the latest image. South Pole current sheet depicted in red. North Pole current sheet depicted in green, rotating out to the west. Here's our line of sight field plot. That is the solar B field depicted in blue. SDO magnetogram, and that might be the gong magnet. I think that's the gong magnetogram. Anyway, magnetogram, north solar polar field in green, south solar polar field in red, and solar B field in blue, the field that goes through the magnet, this magnet being the sun. Next, we'll show coronal holes, and let me bring up the SDO imagery here. There's the gong data. And again, we've got, just like yesterday, we've got some South Pole-oriented coronal holes showing up here in the southeastern limb. We can expect those to become a little more well-defined in the coming days. You can see those showing up there in red. North Pole coronal holes rotating out toward the western limb. There is the view from SDO. That is yesterday plus today. And we can already see these coronal holes down here getting more well-defined as forecast yesterday. Next, we'll move to sunspots. And we've got at least two new groups to get named. So 3282 and 3283 are up here. And we suspect 3284 is also rising behind the northeastern limb. There may be another group or two to get named down here in the southeast as well. So again, we're expecting a large uptick in the sunspot number today and a modest uptick in the 10.7 centimeter radio flux. Oh, and likelihood of solar flares is really high. It's going to be pushing as 32, what is it? 3280, I can't read what that says, but this sunspot right here, as it approaches the western limb, that one becomes much more likely to produce large flares. Otherwise, the high likelihood of flares is mainly in the eastern limb here. So let's take a look at sunspots next. Just give that a minute to initialize here. We will zoom in. Again, that is yesterday plus today so far. There's the full res view of that. Again, 3272 has degraded, but this one up here, which is I think 3282, has grown considerably since yesterday. Also, a couple new name groups down here, and like two new name groups up here also that should get names. And that's some rapid growth up there also. Check out the rapid growth right here. Pretty impressive indeed. As far as energetic particles, we ain't got none. It's been flatlined. So no solar energetic particle events. The likelihood of one of those keeps going up with the likelihood of large solar flares as they usually accompany each other. So here there's a flare going on right now. We'll see where that is a little bit later in the video in our bonus features just before our bonus feature segment. Little solar flare happening as we do the stream. So here is the past 24 hours in 131 angstroms. Pretty low performing as far as flares for the past 24 hours, which is the time frame depicted in this video. We've also got 94 angstroms. These are also ionized iron ultraviolet emissions, by the way, if you're wondering. And here we've combined them. Here's 94 plus 131 angstroms. And it's time for the Smash News Network, least busted name in news, to tell you to step back and look up. Again, I don't know what's going on with my face. Is it coated with dark matter? I think my face is coated with dark matter. We apologize for that, folks. Yeah, WIMPs, a bunch of weakly interacting massive particles have made their way onto my face. Anyway, we encourage you to look up. If you look up over Lehigh Valley right now, this is what will be going on. We've got the moon up there in Capricorn, which means something to somebody. Also, Saturn being chased by Jupiter, being chased by the Sun, being chased by Mercury, being chased by Venus. So if you've got a good view of the sunset, perhaps stick around for a couple of hours and watch Venus and Mercury and Venus rise. Venus probably set to be quite bright at the moment, near the Pleiades after it rises there. Anyway, here's our solar system forecast. Here is where things are now. We'll move this ahead 1 week. Here's where things will be on the 21st. Will be one day after a new moon, and people like you, reverse werewolves, will be very well rested. Next, looking at coronagraphs, and it has been pretty minor as far as coronal mass ejections, I think. There is one eruption there looking like a halo. And I don't think that was a real CME. Anyway, that's 100 frames from yesterday. Here are an additional 37 frames from today. We've got more coronagraphs for you, don't worry. We'll show the view from stereo A also, because sometimes we end up with data gaps and so on. Let's see what we see here. By the way, likelihood of coronal mass ejections in the next 24 hours is nearly 100%. So expect large flares, expect coronal mass ejections, expect an increase in the sunspot number and the radio flux in the next 24 hours. So things are pretty chill here as far as coronal mass ejections go. I don't really see anything that's too exciting going on there. Again, likelihood of additional CMEs incredibly high. Again, nearly 100%. When you see how many filaments are in the Earth-facing portion of the solar disk, you'll probably agree. Let us know in the comments if you agree or disagree. And if you've got some hate comments, please leave them. We find those to be spectacularly amusing. So here's a 24-hour video featuring GOES R 195 angstroms. You can also see Jupiter there sliding out of the LASCO C2 and into the LASCO C3. Pretty chill here. It looks like the calm before the solar storm. So expecting big things in the coming days. Big flares, coronal mass ejections, etc. And again, where do you see the filament situation? Check it out. Here's the ground-based solar observatory at Cerro Tololo, Chile. And look at the filaments. I mean, that's like the Brady... We could name these filaments after the Brady Bunch and still have more filaments than... I guess we can't name them after the Brady Bunch. Those are fictional characters. Anyway, if you want to name filaments, name them after living people and do it on Twitter. There's certainly a variety, like this one here could use a name. That could end up causing aurora visible at your doorstep if it does eject. So if you want to name filaments, make sure you join us over on Twitter. I'm going to tweet right now. Space weather is getting hot, so name that filament. Or a series of filaments. Name them after your favorite or least favorite celebrity, family members, as long as they're still alive. And make sure you go follow us on Twitter. Here's 195 plus 171 angstroms. And let's take a look at the GOES 16, since we have a flare happening as we create the video. So that's the past 24 hours. Here is the past 2.5 hours. And where was the flare coming from? Let us know in the comments what you think. I haven't figured it out yet. I think it's from up here. So yeah, again, the very high likelihood of a sunspot up there, as we're seeing flares long before we even see plasma up there. So that is a flare coming from behind the limb, I believe. And if I'm incorrect, please correct me in the comments. You know, fun fact about the Smash News Network, least busted name in news. When we're wrong, you know what we do? We admit it, get ahead of it, and then move on with our lives. We don't try to gaslight our viewers and everybody else that we encounter on the internet. The ultimate herp-derping is being gaslit on the internet. Next, bonus features. Satellite charging hazards. We have some minor ones here of the surface charging variety moving into the Central Pacific Ocean. That's caused by low-energy electrons which build up on the surfaces of satellites. Again, those are minor surface charging hazards, but that's where they're located. The GOES electron flux is still kind of low here. And, I'm expecting a little bit of an uptick. Let's see what NOAA thinks. And NOAA is expecting flat levels. I'm expecting a little uptick tomorrow, followed by a downtick, especially if there is a coronal mass ejection impact as we forecast. So anyway, that's the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Here's the one-year graph to put that in context. Quite low levels of electron flux here at the moment, but they are fairly orderly. Anyway, first, before we look at the total electron contents, let's look at the F layer of the ionosphere. And folks, feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation. For example, look at the X-rays. You see that? You see how they don't make it to the stratosphere? That's because they're filtered out by the mesosphere layer, and that's why we have to measure them from space. If you're worried about X-rays reaching you when you're on the ground, stop worrying. They get filtered out by the upper atmosphere, the layer below the thermosphere and above the stratosphere known as the mesosphere, which we'll actually refer to later in the video. Anyway, here's the vibrational frequency provided courtesy of Australian Government Bureau of Meteorology. This is showing megahertz, which is millions of vibrations per second, at about 300 kilometers of altitude, one slice of the atmosphere known as the F layer of the ionosphere. Don't be F'd. Understand atmospheric layers. We'll also show the anomalogram, since you may not be familiar with that. Frankly, I'm not that good at looking at the ionogram. Now, of course, if there was one spot of the Earth that I'm consistently looking at all the time, it would be a lot easier. But we always show the full global view. So anyway, that's the anomaly in megahertz from the 30-day median. We'll let that play through once more and bring up the latest image before we go to the total electron content. There's the latest image. That's 1300 universal time ionogram and 1300 universal time anomalygram. The total electron content is the free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with distances to these things in miles. Here is the total electron content for the full globe view. Now, yesterday, North America was not working, so let's bring that back. I'm going to call an audible here. Hopefully that is back live again. Nope. Anyway, there's the full view. We are seeing a little bit of variability there. Some of those electrons are kind of out of place. They're usually focused around the equator around noontime, and we see electrons getting kind of a little bit anomalously far to the south and north, as you may have come to expect by watching our channel. These things typically are associated with low levels of electron flux. Once again demonstrated. The data backing up the other data and the facts backing up additional facts. Here's our latest intensitygram and solar magnetogram. And I'm just going to show you the full disk rock back because, again, we're going to have at least one new named sunspot group, but probably two. Actually, probably like three, because there are two down here that haven't been named yet and at least one up here not named. And this moves us to meteorology. So what we're looking at here is the particulate content. See yesterday's video for an awesome animation about what went on with Shivaluch. Yeah, we showed an animation of the Shivaluch eruption and how the particulate got sucked right into a low-pressure system off the coast of Kamchatka. So that was an ultra-fascinating little video snippet that you could check out in yesterday's Daily Space Weather video. Actually, we're looking at the PM10, the less than 10 nanometer particulate matter. Anyway, transitioning back to Earth weather here. Let's zoom out sufficiently to show the full croissant-shaped Earth projected onto a fake spherical template. Since NASA wants you to believe the Earth is spherical, right? Just kidding, folks. People have realized that the Earth is spherical for over 2,000 years. Anyway, there is the surface wind scenario for the eastern world. Here are the jets of the eastern world. The jets of the western world, otherwise known as the Americas, depicted here. Here are the surface winds for the Americas. Strong winds continue in the North Atlantic. It's been stormy in the North Atlantic for an extended period of time. It's a bad day to be on a boat with Marky Mark and George Clooney. That's a reference to The Perfect Storm, by the way, if you're wondering. I like to make fun of Marky Mark. Surface winds of the central world, like Europe, Africa, and the Middle East, depicted here, and these are the jet streams. Moving right along to our diagram of atmospheric layers. Yeah, our diagram of atmospheric layers. To demonstrate that this is, by the way, temperature at the bottom. That's temperature. This is altitude. The troposphere is warmer at the surface. Most people know this because as you get to about 10,000 kilometers of altitude, not 10,000, 10 kilometers of altitude, it gets cold. The stratosphere remains about that temperature until about 20 kilometers of altitude. Then it starts to get warmer again. The mesosphere starts out warm and gets cold, and the thermosphere starts out cold and gets warm. That's just the way the atmospheric layers are. It's a lot more complex than just hot to cold, cold to hot. It's a little complex up there. We hope you're aware of this. Next, we'll show the clouds and fog scenario over the Americas. This is the shortwave radiation map. The NASA GOES Interactive Weather Satellite 3.9 nanometer infrared radiation. This is a great wavelength to see if you'll be able to see the aurora tomorrow night, as it will show you clouds and fog when it's too dark to see them with the visible satellite. Next, our weather.gov map and lots of red flag warnings. And by the way, additional snow coming. All that hot air coming out of Colorado is not sufficient to prevent additional April snow, as the Ides of April arrive tomorrow. Let's look at some forecasts. Again, if your location is lit, click your location on weather.gov, the official website of the National Weather Service. So here's our temperature anomaly forecast, and expect massive meltwaters to continue as we forecasted over a week ago. When you have a lot of snowpack and spring arrives, you can expect a lot of melting. So this is our temperature anomaly forecast based on a GFS model for the next 72 hours. And you can actually check it out. I see a pocket of hot air right here. Look at that, hot air right there in south central Colorado. Isn't that amazing? I can imagine some hot air sources that come from there. What about you? Next, the 72-hour pressure and precipitation forecast. And there's ice and snow coming to the Great Lakes region. Once again, a huge ice storm there coming to the Upper Peninsula. And also additional snow coming to large portions of the U.S. Also some strong storms, again, like we said yesterday, they look even worse than yesterday, are going to slide along the Gulf Coast again. So be prepared for that. Some heavy weather there at the Gulf Coast. That's a 72-hour GFS pressure and precipitation forecast. We'll also show the total accumulated snow depth forecast, the positive snow depth change in inches for that same model, the GFS 72-hour. Look at that. It looks like that hot air is preventing this part of Colorado from getting any snow. Isn't that incredible? Hot air, the effect that it has on precipitation. Yeah, hot air, it makes clouds evaporate. It changes the dew point. It changes the relative humidity. It changes the air pressure. All right. 72-hour positive snow depth change in inches depicted here. Let's continue on to look at precipitation type, as it is snowing in large portions of Colorado and Wyoming. To a lesser extent, Utah. That is your precipitation type imagery from windy.com, which even has a widget you can put on the desktop of your, quote, smartphone, end quote, device. All right, so let's take a look at Global Cryosphere Watch. We've been sort of monitoring this as we watch the snow melt. The snow extent, which is the two-dimensional amount of area that the snow covers, is right in the meaty part of the range there for the 1998 to 2011 average. The snow mass balance is right in the middle of the meaty part of the range there for the plus or minus 1 standard deviation, the part you see in blue. And the snow water equivalent is way above plus 1 standard deviation. It's dropped down, so some of that flooding has already occurred. A lot of that flooding is still to come. That is a massive amount of water about to be released in spring melts. Next, looking at lightning. We do have some lightning off the coast of North Carolina at the moment. That's the past about 10 hours. Here are the most recent strikes at lightningmaps.org. If you haven't saved that one to a favorite, you're like less safe if a thunderstorm shows up in your area. Lightningmaps.org. And has lightning ceased? For some reason, it didn't connect there. I think we do have some strikes here. What's up with that? You're going to tell me there's no lightning on the whole planet? Looks like some kind of a technical difficulty, and that one is not our fault. Next, we'll close out the video with U.S. Doppler radar as we focus closer and closer on the lower 48. Some precipitation there showing up in southern Alaska. There's what's going on in the lower 48. There is clouds and fog as that low moves up into Tennessee. And there is the water vapor map. Great view of that low. It's not going to be super powerful here as there's not a lot of moisture in it. It's mostly dry air, as you can see. That great counterclockwise rotation there, making its way to the northeast. Water vapor map is the way to figure out what's going on if your Doppler looks weird. Consult the water vapor map. It will probably clear things up, especially if you understand atmospheric physics, and we hope you do. This is your recap U.S. Doppler radar showing vertical motion in the air column. Shortwave radiation satellite showing clouds and fog at 3.9 nanometers infrared radiation. And 6.19 nanometer infrared radiation shows the water vapor. Anyway, once again, thanks for tuning into the Smash News Network, least busted name in news. Please support the channel by pressing like, subscribe, share, etc. Maybe tell your friends and foes about it. Thanks for leaving a comment. Tinman1057, good morning to you as well. And don't forget to visit the links in these type of areas. We'll see you soon, and may that solar wind be at your back.